Okay, this particular technology was developed during the time of my PhD student, Muhammad. But I sent him to Czech Republic for a resuscitation meeting, so I have to come here to give you this explanation of what this technology is about. So every one of us know that hypothermia, or cooling the body, is protective, particularly to the brain. So therefore, in the past several decades, it has been tried out both in experimental studies as well as in clinical studies to reduce the brain damage, specifically coming from cardiac arrest. That if the patient is resuscitated, they may have sustained brain damage, and how to control that. So that's one. Or you could have traumatic brain injury, or stroke, or suffocation during birth. So how do we cool the brain? So therefore, this effect is known, and kind of physiologically and pathologically, I think hypothermia is what we call a pleiotropic effect. That means it is a multifactorial protection of the brain. So it not only decreases the metabolism, it would decrease inflammation, it would decrease neuroexcitotoxicity, it would decrease apoptosis. So therefore, it is a fundamentally very interesting and very effective method. All the drug companies in the past several decades has pumped billions of dollars trying to do neuroprotection, and particularly in stroke, and they all end up fruitless. So that is what we call the graveyard of neuroprotectants. And hypothermia is the one that is very effective. So of course, this is a problem that has been pursued by many, many different companies. But the two major characteristics in order to make hypothermia to be feasible in a clinical environment is that it has to be simple, and it has to be cooling down the brain very rapidly. So you do not want to wait an hour before. You could cool down the brain to between 32 and 34. That is the therapeutic range that is published in the American Heart Society's guidelines. So, and also is that you do not want to use a technique that is invasive. Currently, there are methods where they would put a catheter into your descending aorta and circulate cold water in it, so therefore you will cool down the blood and then cool down the brain. Or another extreme method is to make a hole in your abdominal cavity and infuse cold saline into your abdominal cavity, and then you rapidly cool down your body. But that trial was stopped early because of severe complications. So we have hit upon a method which is very simple. By blowing cold air into your nostrils, you will think that, oh, why does it work? And that is because of the unique anatomy of our human body, that the two major blood vessels that supply the brain passes through the cavernous sinus. And the cavernous sinus is collecting all the blood that is draining the nasal cavity. So therefore, if you cool down the nasal cavity, those venous blood will be cooling the incoming warm blood to the brain. And then you will be able to cool down the brain very effectively. And then how do you generate cold air? The cold air is generated by a technique that is well known in industry. So if you guys has watched that Ebola virus in that level 3 facility, you see the people have a piece of metal tube in their gown, and that is a vortex tube, because it uses compressed air and then generate the cold air. So there is no electricity, no mechanical parts, no chemical, etc. And it is very compact. The diameter of it is 5 centimeters and is long about 27 centimeters. So we have done that experiment. And then you just blow the cold air. And the way that we are going to do it is using a CPAP machine's mask, so that you have a nose pillow that blows into your nose. And we have done it in rabbits, in 6 rabbits. We are able to cool down the brain into the 32 to 34 range within half an hour. And then we could maintain it for as long as we want. So therefore, this method, to summarize, is very simple and effective, and is very inexpensive. And the more compelling aspect of it is that you could use it in the hospital or out of the hospital. That means you could even use it on ambulance, on route to hospitals, or you could install it in all public places, just like nowadays every mall has a defibrillator, just in case someone passes out, and they could defibrillate the patient, the person. So here, you could have this device, and then you could immediately cool down the brain while you're waiting for the EMS to come. So, and now we have submitted a patent, and this project is currently funded by the Western Innovation Fund for us to translate it into the clinical environment. Thank you.
Well, thanks very much. I haven't even spoken yet. And Ting stolen most of my thunder. So Ting touched on a lot of the advantages, and one of the great benefits that we see from this device is the fact that it is robust and doesn't require consumables to be pumped into the individual to achieve brain cooling, and it's very selective, meaning that you are only cooling the brain, and the rest of the body and all of the associated problems that would come from whole body cooling are avoided. We filed for patent protection on this, and we've received very favorable initial review at the international stage, so we're very confident that the claims that we secure will cover the commercial embodiments. If I'm just thinking ahead to whoever may take up this project and thinking about your business plan, some of the points that need to be considered and that come from some of the initial discussions that we've had with industry are validating the various markets that Ting has identified. So the primary market that we see obviously is in brain injury, traumatic brain injury, stroke, whereby the device could be deployed in a hospital or in an ambulance so that the patient could be treated en route to the hospital. And we have some initial estimates on that market size, could be as much as $300 million in North America alone, depending on what kind of rate of adoption that we might see. But there's also some secondary markets that we might like to see validated as well. And one of them, we had some initial talks with a company that develops military vehicles. So you can imagine a military vehicle gets hit with an IUD, there may be some brain injury, but you're in a battlefield and the ability to treat a patient may be difficult. Ting's device just requires a source of compressed air, and the way that you generate the cooled air doesn't require any moving parts. It's going to be very robust and very stable. Other avenues, other markets that we could see, and Ting, maybe you can speak to this, is potentially the ability to treat chronic diseases like MS. Is that a potential application as well? And again, just like you see the portable defibrillators deployed in places like hockey rinks, and that you could see a device similar to this to potentially treat things like concussions or even worse, more traumatic brain injuries. So some of the considerations that we've been alerted to are coming up with a path to market. Is this enough that it could support a business? How best to productize the technology? So we envision selling the hardware. That would be a one-time sale, but also there may be some software associated to automatically control this, as well as what consumables might be for sale so that you can have an ongoing stream of revenue. And the fact that it's a medical device poses some potential regulatory hurdles, but we think there's sufficient similar devices on the market as predicate devices that could mitigate that. And Ting, I think you've tested it on yourself, so you're still here. Yeah. So that's a benefit as well.
So very coherently too, I might add.
Right. So, but then kind of, I think for the internal testing within this institution for clinical testing is fairly simple because it is constructed within our site and we are using on our own patients. So that wouldn't present a hurdle. The hurdle will only come that when we want to kind of take it to other institutions, either for kind of multi-center studies or to commercialize it.
So again, thanks for your time, and Dr. Lee and I look forward to seeing the creative ways that people come up with how to bring this from the benchtop to the market.
Thank you.